Right now, beneath the island of Hokkaido in northern Japan, a slab of ancient ocean floor the size of a small continent is being swallowed into the earth at a rate of 82 millimeters every single year. That is slower than your fingernails grow. And yet that creeping, grinding, unstoppable descent is the reason that at 5:23 this morning, while most of Hokkaido was still dark and silent, the ground beneath 5.2 million sleeping people moved without warning. But that is not even the real story. Because what happened this morning, a magnitude 6.1 earthquake striking 37 kilometers southwest of the city of Obihiro at a depth of 81 kilometers below the surface, is not a single event. It is not a random tremor. It is not a statistical blip on a seismograph that scientists will quietly file away and forget. What happened this morning is a signal. A data point in a sequence that has been building in this exact corridor of the Japanese archipelago for decades, and what the data actually shows is something that the people waking up in Obihiro this morning have no idea they are living inside of. The ground they walked on today, the roads they drove to work, the farmhouses their grandparents built in the shadow of the Hidaka Mountains, all of it sits directly above one of the most tectonically compressed and mechanically stressed regions on the face of this planet. And the system is not dormant, it is awake. It has been awake for a very long time, and this morning it reminded us. Let us start with the numbers, because the numbers are where the story lives. The United States Geological Survey registered this earthquake at a moment magnitude of 6.1, with a hypocentral depth of 81 kilometers. The European Mediterranean Seismological Center confirmed a magnitude of 6.0 at 79 kilometers. But here is the number that should stop you. Japan's own National Research Institute for Earth Science and Disaster Resilience, the agency with the densest seismic monitoring network on Earth, reported this same earthquake at a magnitude of 6.5, a full half magnitude higher. That is not a rounding error. On the logarithmic scale by which earthquakes are measured, a half magnitude difference represents approximately 2.8 times more energy released. The same event, the same shaking, the same morning, and the most sophisticated national monitoring system in existence measured it as nearly 3 times more powerful than the initial international estimate. That discrepancy alone tells you something important. Seismology is precise, but it is not certain. And in a region like this, uncertainty is its own kind of danger. The epicenter sat 18 kilometers west of the tiny town of Sarabetsu, a community of roughly 3,275 people tucked into the agricultural flatlands of the Tokachi plain. To the northeast, 37 kilometers away, lies Obihiro itself, a city of 165,151 people. The agricultural heart of Hokkaido, built on some of the most productive farmland in Japan, surrounded by potato fields and dairy farms, and the quiet domesticity of a city that prides itself on being steady and reliable and rooted in the earth. The irony of that last fact is not lost on anyone who studies the geology beneath it. This morning, people in Obihiro felt the ground move at modified Mercalli intensity scale level 5. Moderate shaking. Objects falling from shelves. The kind of shaking that wakes you from sleep with your heart already hammering before you are fully conscious, and that reminds you in the most visceral possible way that the ground beneath your house is not the solid, permanent thing you spend the rest of your life pretending it is. Sapporo, the capital city of Hokkaido, home to nearly 2 million people, felt it as a level V, light shaking, 140 kilometers to the west. Tokyo, 822 kilometers to the south, felt it as a whisper. But between Sapporo and Obihiro, across the Tokachi plain and into the foothills of the Hidaka Mountains, 339,000 people experienced shaking classified as moderate. Another 4,272,000 people felt it as light shaking. Rattling windows, swaying furniture, the particular unease of a world that is supposed to be still suddenly demonstrating that it never really is. Add the 593,000 who felt weak shaking at the fringes of the affected zone, and you arrive at the number the headline already told you. 5.2 million human beings touched by this single rupture this single morning. 5.2 million people who felt in that moment the 81-kilometer deep message that the Earth sent up through the rock. And here's where this story becomes genuinely alarming, because this depth, 81 kilometers, is not the shallow brittle fracture zone where most people imagine earthquakes happening. This is intermediate depth. This is the Wadati-Benioff zone. This is the interior of the descending Pacific slab itself, bending and flexing and fracturing as it is forced down into the mantle beneath the Okhotsk microplate at a convergence rate between 7.9 and 9.2 centimeters per year. Picture what that means. The Pacific Plate, a slab of oceanic lithosphere that has been subducting beneath this region for close to 100 million years, is plunging into the Earth at this location, and the Wadati-Benioff zone beneath Hokkaido extends to depths of 650 kilometers. 650 kilometers. That is deeper than the distance from New York to Boston, measured straight down into the planet. The earthquakes generated in this zone are not surface fractures. They are the groan of an entire oceanic plate bending under its own gravitational weight as it descends into the mantle. And the shaking they generate does not behave like shallow earthquakes. At intermediate depths, seismic waves travel through denser, more efficient rock, and they radiate energy outward across enormous distances with a persistence that shallow earthquakes do not possess. That is why 5.2 million people felt this one. That is why it was measured as far away as Tokyo. But even that is not the full picture, because this earthquake did not happen in isolation. It did not fall from a seismically clear sky. 7 days ago, on April 20th, 2026, a magnitude 7.4 earthquake struck the Sanriku coast of Honshu, 298 kilometers to the south of this morning's epicenter. That earthquake, a thrust rupture along the Japan Trench where the Pacific Plate dives beneath the Okhotsk microplate, triggered an immediate tsunami warning. An 80-centimeter wave was recorded at Kuji Port. The Japan Meteorological Agency issued an off-the-coast of Hokkaido and Sanriku subsequent earthquake advisory, warning of the possibility of a stronger event to follow, and stating that the probability of a megaquake exceeding magnitude 8 had been elevated tenfold. From a background probability of 0.1% to a still small but no longer negligible 1%, and before that, on December 8, 2025, a magnitude 7.6 earthquake struck in the same broader region. 3 significant earthquakes in under 5 months. The most recent of them striking at 5:23 in the morning, 7 days after the magnitude 7.4, while the stress distribution in the crust and upper mantle around this section of the Japan Trench is still actively reorganizing. The question is not whether this region is geologically active. The question is what the sequence means. Now let us anchor this in something real, something that has already happened. Something that is not theory or projection or model output, but documented geology and documented history and documented loss. On September 26, 2003 at 4:50 in the morning, note that time because the geography of disaster in Hokkaido favors the dark hours, when people are asleep and evacuation is slower, a magnitude 8.3 earthquake struck off the southeastern coast of Hokkaido in the Tokachi region. It remains the strongest earthquake anywhere on Earth in that calendar year. The epicenter sat approximately 60 kilometers below the ocean floor, roughly 100 kilometers offshore, and the rupture area covered a patch of the plate boundary approximately 240 kilometers long and 210 kilometers wide. The shaking lasted for about a minute. 1 minute of ground movement that damaged roads all across Hokkaido, triggered power outages across the prefecture, caused widespread liquefaction of the coastal soils, and sent a tsunami racing toward the eastern shores of the island. That tsunami reached a maximum run-up height of 4.4 meters, nearly 15 feet, along the southern Hokkaido coastline. It swept 2 fishermen into the Tokachi River near the town of Toyokoro, killing one of them. It destroyed oceanside communities. It damaged 123 coastal fishing ports in eastern Hokkaido alone. The total economic cost was estimated at approximately 213 billion Japanese yen, or $1.9 billion US dollars at the time. Over 850 people were injured. And in Obihiro, the same Obihiro where 165,251 people woke up this morning to a magnitude 6.1. Buildings experienced severe damage in 2003. Structures in Kushiro, Tokachi, and Hidaka sub-prefectures reached Shindo 6- on the Japan Meteorological Agency scale and IX on the modified Mercalli scale. The most advanced seismically prepared nation on Earth absorbed a magnitude 8.3 like a body blow. And here's what makes 2003 so important to understand right now. The 2003 Tokachi earthquake was the third event of magnitude 8.0, or greater, to strike the southeastern portion of Hokkaido in the 50 years prior to it. There was a magnitude 8.2 in 1952. There was a magnitude 8.3 in 1968. Each of these events occurred in approximately the same zone. Each of them ruptured a different segment of the same plate boundary, filling in the seismic gaps left by previous events, the tectonic stress accumulating and then releasing in a cyclical pattern that researchers have traced back through tsunami deposits laid down in the coastal sediments over the past 5,500 years. Those sediment layers tell a story that instrumental seismology only began recording a century ago. They show that this region has produced mega-tsunami-genic earthquakes at intervals of roughly 450 years, events so large that they deposited sand and marine material deep into the coastal lowlands of Hokkaido, events that geologists can date, that they can measure, that they can use to build a recurrence model. And the data from that sediment record shows intervals between great ruptures of this zone ranging from decades to centuries, with no clock, no timer, no warning light. The monitoring is in place and detection is possible, but prediction is not. Think about what that means for the town of Sarabetsu, a community of 3,275 people, most of them farmers, living in homes built on the alluvial soils of the Tokachi Plain, 18 kilometers from where the ground ruptured this morning at 5:23 a.m. What does the morning look like in Sarabetsu? Dairy farmers already up before sunrise, checking on their herds. Potato fields stretching toward the horizon in the flat, open landscape that makes Hokkaido feel like it belongs in a different country from the rest of Japan. Children getting ready for school, the low mountains of the Hidaka Range visible to the west in the early light. And beneath all of it, 81 kilometers down, a slab of ocean floor grinding forward at 82 millimeters per year, accumulating the stress that makes mornings like this one possible. The people of Sarabetsu and Obihiro and the Tokachi Plain do not live in ignorance. Japan is the most earthquake-prepared society in human history, with building codes that have been revised again and again and early warning systems that can push alerts to mobile phones in the seconds before shaking arrives. But those systems depend on the gap between the origin of the earthquake and the arrival of the shaking. At 81 kilometers depth, directly beneath the region, that gap shrinks. The warning is shorter. The seconds are fewer. And this morning, those 3,275 people in Sarabetsu felt their houses move before most of them had fully registered why. Now let us go deeper into the geology, because the geology here is more complicated and more dangerous than it appears. This is not simply a subduction zone. Beneath southern Hokkaido, something additional is happening that seismologists call the Hidaka collision zone. As the Pacific plate subducts beneath the Okhotsk microplate, it also carries with it the Kuril Island arc, the chain of volcanic islands running northeast from Hokkaido toward Kamchatka. That arc is being compressed against the northeastern Japan arc, driving the two continental structures into each other in a collision that is building the Hidaka Mountains, folding and thickening the crust, and generating northwest-southeast compressional earthquakes that are fundamentally different in character from the offshore subduction zone events. These are crustal earthquakes, shallow, high acceleration, and locally devastating. In 2018, a magnitude 6.7 earthquake struck in the eastern Iburi district of Hokkaido, a direct product of this arc-arc collision with a focal depth of approximately 37 kilometers. That earthquake killed 41 people and injured 691. It generated peak ground accelerations of up to 1,096 gal, nearly 18 times the force of gravity recorded at the ground surface. It triggered serious and widespread landslides across the region. It caused unprecedented damage, and it came from a fault system operating at much shallower depths than this morning's event. The 2018 Eastern Iburi earthquake and this morning's M6.1 are products of the same collision geometry, the same compression, the same plate boundary dynamics, but they release their energy in different parts of the system, at different depths, and through different mechanisms. The seismic velocity structure beneath the Hidaka region shows a broad low-velocity zone of crustal rocks west of the Hidaka main thrust at depths of 35 to 90 kilometers, and today's earthquake at 81 kilometers sits directly within that zone. Scientists at Hokkaido University and Tohoku University, who have been mapping this structure for decades using data from both permanent seismic networks and temporary deployments, have stated clearly in the published literature that large earthquakes will take place again on the active thrust faults in southern Hokkaido in the coming decades. This has already happened once. The evidence is still there in the fault plains and the tsunami deposits and the accelerometer records and the geologic cross-sections. It will happen again. And now we must talk about the connection to the larger Earth system, because what is happening in southern Hokkaido is not happening in isolation from everything else on this planet. The Pacific plate that is being subducted beneath this region is a single continuous slab that connects the seismicity of Hokkaido to the seismicity of the Tonga Trench in the South Pacific, to the Kuril Trench, to the Aleutian Arc, to the Cascadia subduction zone off the coast of North America. Stress changes generated by a large earthquake on one segment of a subduction zone do not stay contained within that segment. They propagate, they redistribute, they can promote or inhibit future earthquakes across enormous distances along the plate boundary. The magnitude 7.4 on April 20th changed the stress field in the crust and upper mantle around the Japan Trench. This morning's M6.1 is occurring within a system that is already responding to that stress change. What the data actually shows is a region that has produced 3 significant earthquakes, 7.6, 7.4, and now 6.1, in approximately 5 months. Whether that sequence represents a main shock-aftershock relationship independent events or the precursory loading of a larger future rupture is a question that no monitoring system on Earth can currently answer with certainty. There is a second connection that the data suggests and that the science is still learning to measure. Solar activity in Earth's geophysical systems are not as independent as classical science once assumed. Research published over the past 2 decades has begun to document correlations between periods of elevated geomagnetic activity and increases in shallow seismicity, particularly in regions of high crustal stress. The mechanism is not fully understood. What is understood is that the Earth's lithosphere is not a passive, inert system. It is electrically and magnetically coupled to the space environment through the ionosphere, and the compressional and extensional stresses in the crust are sensitive to changes in that environment in ways that researchers are still quantifying. This is not a theory. This is documented geophysics. And it means that the crustal stress environment beneath Hokkaido is influenced not only by plate tectonics, but by the broader electromagnetic state of the planet and the activity of the sun. The Pacific plate subducts, the Hidaka collision zone compresses, the solar wind interacts with the magnetosphere, and somewhere in the intersection of all those systems, at 81 kilometers below the Tokachi plain, at 5:23 on a Monday morning, the rock broke. Here's what that means for the 165,851 people of Obihiro. They woke up this morning to a Shindo 5, by the Japanese intensity scale, that is strong enough to cause most non-anchored furniture to move, to make it difficult to walk, to break window glass and crack plaster walls. In the older residential districts of Obihiro, in the neighborhoods built before the 1981 revision of Japan's building code, before the country overhauled its seismic standards in the aftermath of the 1978 Miyagi Prefecture earthquake, there are structures that were not designed to the current standard. Retrofitting programs exist, and Japan has committed enormous public resources to them. But in a city of 165,000 people spread across a landscape of farms and residential neighborhoods and commercial districts, not every building has been upgraded, not every shelf has been anchored, not every family has done the calculation about what lies 81 kilometers beneath the earth their house is built on. This morning, some of those families did the calculation whether they wanted to or not, and there is one more number to sit with. In only 6% of cases, according to the statistical record of global seismicity, does a significant earthquake turn out to have been a foreshock, a precursor to a larger event rather than the main shock itself. 6%. That sounds reassuringly small, until you remember what it means in a region where the seismic record already includes M8.3 events. Until you remember that the Japan Meteorological Agency's advisory, issued after the April 20th M7.4, explicitly warned of the possibility of a subsequent stronger earthquake and listed a non-zero tenfold elevated probability of a magnitude 8 or greater. Until you remember that the research on this zone shows earthquake sequences involving multi-segment rupture, that the 1952 event ruptured a different segment than the 2003 event, and that the geological and sedimentary evidence suggests the potential for combined Tokachi-oki and Nomura-oki rupture producing something larger than either event alone. 6% of the time, what looks like a main shock turns out to be a foreshock. Scientists are careful to say that, but that careful language carries its own warning. The monitoring is continuous. The seismographs do not stop recording. The tide gauges on the eastern Hokkaido coast are running right now. The GPS stations across the Tokachi plain that measure millimeter-scale crustal deformation in real time are uploading their data right now, and the scientists reading that data are measuring things they can detect but cannot predict. In Sarabetsu this evening, 3,275 people are going about their lives. The potato fields are as they were this morning, and the dairy herds are placid in their stalls, and the low mountains of the Hidaka range are catching the last of the April light. The town does not look like a place under threat. The shaking this morning was moderate, and it has passed, and the day has continued. The aftershock risk is decreasing with every hour that passes without a stronger event. But 81 kilometers below Sarabetsu, the Pacific plate is still moving. It does not stop. It has not stopped for 100 million years. It is moving right now at this moment at 82 millimeters per year, dragging a column of old, cold, dense oceanic lithosphere down into the mantle, building the stress that this morning partially released, and that begins accumulating again the moment the shaking stops. The system is not dormant, it was never dormant, and the next time it speaks, it will not ask whether you are awake to hear it. The real question, the one that the data raises, and that no instrument currently in existence can answer, is whether what happened this morning at 5:23 a.m. was the story, or whether it was the opening sentence of a longer story that has not yet been written. 8 magnitude 6.1 or greater earthquakes have struck within 300 kilometers of this epicenter in the past decade. That averages to once per year. The region has produced M8 class earthquakes in 1952, 1968, and 2003, approximately once every 25 to 50 years. The most recent of those was 22 years ago. The accumulated strain since 2003 has not been fully released. The geological sediment record shows events larger than the instrumental era has ever witnessed striking this same coastline at irregular intervals over the past 500 years. The monitoring systems are in place. The early warning infrastructure is among the best on Earth. The building codes are among the strictest. Japan has done everything that science and engineering currently allow to prepare. And still at 5:23 on a Monday morning, the ground beneath 5.2 million people moved without asking permission. The Earth does not consult the seismograph before it acts. It acts, and then the seismograph records what happened, and then the scientists interpret the record, and then the rest of us try to understand what the interpretation means. What it means is this: the system is loaded. It has been loaded before. Every single time it reached this point in its cycle, the rock eventually broke. The only variable the science cannot give you is the one you most want to know, not whether, when.